Good afternoon, all. Hello and welcome to designTimber. My name is Tabitha Binding. I'm Head of Education and Engagement for Timber Development UK, and this is the second series from TD UK, where we are creating the opportunities to learn directly from the multidisciplinary teams behind incredible projects, selected from the Wood Awards in 2022. As people come into the room, I'd like to tell you a little bit more about Timber Development UK. We have formed from the merger of the Timber Trade Federation and TRADA. By bringing these two associations together as one, we've created the largest, most comprehensive supply chain body in the UK, spanning from sawmill to specifier to finished project and all the points in between. Our mission is for timber to be accepted as one of the major materials suitable for construction projects in the UK and as one of the best routes to decarbonise the built environment. So we are seeking to connect the supply chain, lead best practice, and accelerate a low carbon future. And to do this, we are delighted to learn from our professionals who won certain categories in the Wood Awards 2022. So today, in the second of the designTimber series, we will hear from the team behind the water tower, one of the amazing entries. If you have any questions, please pop them in the Q&A and we'll come back to them at the end. And so without further ado, I'd like to introduce our speakers today, who are it's been lovely to talk to them before we started. They are very friendly, get on really, really well, and there's been a lot of banter, but there's also a lot of lessons that we can learn from them. So our speakers are Mike from Tonkin Liu, Mervyn from Rodrigues Associates, and Dennis, who's the proud owner of the water tower. Gentlemen, I'd like you to take the floor.
Thank you. Thank you. So I'm going to share my screen. Yep. Are you seeing that?
Yes.
So just quickly to begin, we're going to kind of show you how the tower was thought about, and Mervyn and I are going to do a double act. I'm going to say what the intention was, and Mervyn's going to say how we did it. I think that's probably what we're talking about. So just very quickly at the beginning, so we have Tonkin Liu have a design methodology, which is called asking, looking, playing, making, which is a way of interrogating a project to make it specific to the circumstances. So we always look at nature, people, and place. The place is really amazing. So Castle Acre is, as the name suggests, full of castles and ruins. It has a Norman castle, which is the best in the country, a priory, which is incredible, and a Bailey gate that used to protect the village. So all of these ruins are incredible, but there's one more ruin, and that's at the top of the village, up here, and that was for ruined water tower. And when Dennis called and said he bought a water tower, I think none of us pictured this in our minds. So Dennis bought this. He was buying it at auction. He'll tell you more about that, but he was bidding against someone who wanted it for scrap metal. And Dennis has managed to turn this into an amazing project. So, as a couple, Dennis and Missia, they've always, I think Dennis has always had an interest in the mechanical and all things somehow have that sort of property, but about how things work, and very interested on that level. He's a photographer, and Missia is a costume maker. So there's an interest in how things work and how they look as well. And when Dennis first showed us the tower, we went and had a little tour, and you climb up on the outside and going through the hatch in the top into this sort of dark tank. And he you know, it was obviously an incredible vision to buy this steel water tank, but he had sort of very big ambitions for what he wanted to do with it. So in terms of nature, we always look at what the thing is in its essence, and here this is obviously a tank of water on top of a hill. And in terms of framing nature, say when we did the singing green tree, we're framing the wind to give the sound of a singing green tree. In the sun rain rooms, we frame the rain. And here, basically, we tried to make a device that's about sort of framing the changing elements through the changing seasons. And as a symbol, it's kind of like a symbol, it's like a ruin, like the rest of the water tower. And learning, we're going to show you maybe somehow how we've learned from nature a little bit as well. So, so the tank's made up of several pieces, and we're just going to go in and explain those. So basically, the tank is at the top. There's a stair to one side because we couldn't come up through the bottom because there's a steel structure holding up the tank. So we infilled the underside of the tank under the frame, and we built a bridge between the two. So it's basically made like a kit of a family of parts, and we're going to go run through that family of parts now. And then afterwards, Dennis is going to then take us on a tour through the building. And so we're going to do this tour in the way that Dennis is going to do it from the bottom up. So we're going to talk about the frame first. So the frame basically was a very slender, delicate structure. The water tower swayed a lot in the wind.
Basically 4 columns with a huge tank on it and very little else.
And the weight of the tank was something like...
Well, we think about 2,000 kilonewtons for the weight of the tank plus the water.
And that was, and I think it was the equivalent of an 8-story building.
Equivalent to, yes.
On top of 4 very, very delicate columns. So yes. In the wind, it swayed around like nobody's business.
Yes. And the advantage about the water tank as it was that it was just a tank with 4 columns underneath. So the wind blew through. And the complication which we created was to create a greater wind elevation, which we had to deal with. But I'll talk about that shortly.
Yeah. And one of the things about the frame was that so each of those elements we're going to talk about, in each one we wanted to make a different relationship to nature. And this one, it was about making rooms that faced over these beautiful barley fields that stretch out to the horizon, and the wind blows over them and makes incredible kind of patterns. So it also pointed the windows away from the village, and we'll explain that as we go through. So I think, Mervyn, do you want to talk about the structure?
So the existing water tank is basically a series of RSJs, secondary RSJs supported on 2 primary RSJs, which then sit on the 4 columns. And to stop the columns from buckling, there's horizontal and diagonal cross bracing. And one of the things we had to do is to actually cut through some of the diagonal bracing in order to create access through. What was quite remarkable was that even though the steel has been around since early 20th century, 19th, it really hadn't deteriorated very much at all. A little bit of surface rust, but nothing significant. And that's because it was exposed. The one thing we had great confidence in was the foundations, because it was carrying 2,000 kilonewtons, and it didn't matter how much weight we added on, it wouldn't get anywhere near it. So we were confident that foundations would never be a problem.
In fact, Mervyn, you wanted to make the building as heavy as possible, didn't you?
Indeed, yes, yeah. Yes, and that's to help sort of create a mass at the top of a building, a bit like how they put masses at the top of tower blocks in earthquake condition environments. That's to stop it from swaying, to give it a inertia. So that helped as well.
Yeah. And we looked at lots of options of how to infill the frame, and we looked at doing zips panels and studs and stress ply. But the one that made the most sense was to do it in CLT. And we'd done a CLT building together in Kingston, where we'd used kind of CLT and done some interesting things with compression and separating out the tension. And actually what was interesting here in that project, we were using the steel to strengthen the wood, but here we did exactly the opposite.
Yes, in fact, the contribution of the CLT in terms of adding to the stiffness of the building was significantly 10 times more than the stiffness capacity of the steel tower. So we actually created almost a composite structure in which we share the load between the steel tower and the cross-laminated timber structure at each floor level and at each node level. So we didn't introduce any additional local bending into the steel structure, but we actually shared the load and used the CLT to provide additional stability to the tower.
So I think we're going to show you some pictures of the inside. So this is looking north, so looking towards the kind of barley field, and here the frame is up above from about where the window starts, and we're sort of back in the plan where the staircase is. So it makes a sort of long, thin room, and this becomes a kind of garden room that's all about sort of being down at ground level. It's a sort of rumpus room, extra beds of air. It's got a small kitchenette, and it's part of the sort of garden living space. And it has, there's the kitchenette, and it has all the plant in it too. And then the door you're seeing in the background there is the door into the lift. So these are the plans of further up the tower. So the tower basically has the bedrooms in it, but each bedroom has a bathroom and a small storage. And then on top of that is a small mezzanine. And maybe Mervyn will explain structurally how that's all works. I think the two plans on the right are probably the relevant ones.
Sure. So the one on the left-hand side just shows you the ground floor, and it shows you the concrete bases for the foundations and the perimeter and the slab, ground-bearing slab for the ground floor. But then when you go to the center one, that's a typical floor plan, shows you the cross-laminated timber spanning from right to left and spanning onto the perimeter walls. And then you have the mezzanine, which also spans, clear spans across the width of the room from right to left. And then
it also helps to add stiffness, doesn't it? I mean, the corners are the interesting bit.
Yes, the corners are a very interesting bit, and you can see where we've had to chop through the cross bracing in order to create access at each level via a bridge to the tower. And we took the existing steel structure and we cut it, and then we created some K bracing. And then I did a quite complex exercise of looking at the relative stiffness, and that's when I really found that the cross-laminated timber was significantly more stiff than the cross bracing, and that was a great relief for me. So, and if you look on the image on the right hand side, you can see the diagonal struts between the laminated timber and the node points of the tower, and that's how we're able to share the load, but allow one to move relative to the other. So it was a constant sharing of load, but because the steel will move differently to the timber, we allowed a relative movement as well. So that's quite a key detail which we added to the structure.
The other thing the elevation shows on the left there is actually this open air in between the top of the infilling of the tank and the steel tank above, because so there's a sort of thermal break there. So we had a kind of roof under the tank. So inside the tank, Dennis will walk us through there later. So the ladders that were in the tank that led you up to the tank were all reused to go to the mezzanines. And the bars on the wall there, they're part of what was inside the tank, which you'll see later. And we put these big windows facing north, but we also put two side windows on either side. One so that you could look at, so on one level you could look to see who was coming, one at low level and one at high level, like the windows in the buildings in Yemen, because one lets in the cold air and one lets out the hot air. So there's a high and a low window, and that's looking back across to the bridge. And then this is the bathroom. And the bathrooms have all been covered in fiberglass panels, and each one is a different color. So as you move around the building, and you'll see that the windows, these are Velfac windows, but we've taken the inner lining all the way up to meet the glass, so the window sort of disappears like a castle. And there's the mezzanine with it. It also has its own little window. That's for heat out, and wakes you up in the morning if you're up, as that one's facing east. So that gives you the kind of view from the mezzanine. And there's the picture on the right there shows the sort of morning sun projected onto the western side. And it also shows you the window detail of how the CLT is then kind of lined with a piece of plywood that covers up the CLT and the insulation before the corrugated skin on the outside. And there was a very nice video of that wind, that curtain blowing in the wind, but I couldn't get the video to work, Dennis. So it's just a still of it. And on the outside, the tower is basically clad in wriggly tin. We did consider timber, but for Dennis, the timber represented more maintenance, more work, and more cost. And actually, this was the most cost-effective way of doing it. It gave it longevity, but it also gave us lots of other advantages you'll see as we go through the pictures, because it makes the tower kind of reflect the environment. And maybe Dennis will tell you a little bit about that. And then so you're in these kind of barley-coloured rooms, I should say, rather than honey-coloured, barley-coloured rooms that look out over the barley field. And then they are connected then to the bridge. So the bridge structurally also is quite interesting. But what it does for you in terms of nature is it faces east and west. So it sees the sunrise and the sunset. You're sort of elevated in space, going through the K brace, as Mervyn showed you. And it's just made of large sheets of glass. And it doesn't matter that it gets hot, because all of that heat goes into the thermal chimney of the staircase. So there you just see straight through it. And yeah, you're sort of elevated at the height of the trees, basically. So you're sort of hidden. So you're exposed for a moment, but that's if there's anybody about, which there's generally not. And then you're sort of walking through space across the bridge into the tank, and you sort of see the outside. You go from the inside to the outside almost, and that's where the K brace is. And that's just another view reflected as you come across. And looking at that's when the barley field hasn't yet grown.
Just a note about the bridge. We used a double layer of CLT in order to span across the between the stair tower and the rooms, and that's because each floor supported the glazing, but we didn't want a downstand beam or an upstand beam, so we just increased the thickness in order for it to work.
And there you're seeing. So what we were saying about the cladding is that it basically sort of reflects whatever colour the sky is. And Dennis told us that someone called him and said it looked like the water tower was on fire because it was reflecting the orange of the setting sun. So that was I don't think that was caught on camera though, Dennis, was it?
Yeah, I have caught it on camera, but I just haven't posted it or shown you, actually. It is okay. It's a good shot. Yeah.
Okay, all right, we'll have a look at that in a tick then. That's great.
Yeah.
And then the stair. The stair is an interesting one because the tank is obviously very filigree and almost flimsy, and we could get a certain amount of stiffness about putting the CLT box into the frame of the underneath there, but actually we still needed more stiffness because the tank was still going to move around in the wind. So actually we used the stair tower to strengthen it. And this is where we're kind of learning from nature. So the tower is a very closed structure, and inside that very closed structure, we put a compression spiral. So this is learning from a gastropod has a spiral in the center of it. So any force that's put onto the shell is taken into the center and then redistributed. And these staircases in sort of Georgian houses are cantilevered stone stairs, basically work in the same way. If you go to France, you'll see that the staircases generally fan. And in England, generally staircases go straight and then have a kind of corner in the quadrant. And actually, we think the French version is much more beautiful because it's more organic. So here, we basically made something that looks like two steps, but it's actually sort of one, and it's adding strength. So, yeah.
So as Mike said, the staircase is just a compression spiral. And simply supported in the perimeter walls, and then the compression spiral is then supported on a local thickening in the slab, and that's really as simple as it can get. And the compression spiral adds to the stiffness of the box in terms of stability.
And over on the right there, you see the wall. Mervyn calculated the wall. It's 4 stories tall, and it only needed to be 80 mil.
Yeah, 80, yeah.
81.
81.
We couldn't get 81, so it ended up being 100, I think. But it was interesting in terms of the cost. If most architects will know that a stair generally costs about 15,000 per flight, up to 30, 50, whatever it is. But actually, this staircase is a remarkably cost-effective way of making a stair. The CLT pieces were cut. They were nested onto a sheet and then cut from templates, and they cost 3,500. It took Nigel and Ben, who were the main guys helping Dennis with the construction. It took them only 1 week to go from the top to the bottom, screwing it as they went. So if you take their cost and the cost of the wood, then the whole stair cost about 7,000, and that's 4 stories tall. So it's not 15,000 a flight; it's like 1.5 or something. So so it's an incredibly cost-effective way. And then the balustrade was then made out of the rods that you'll see that came out of the tank, and this is a view from the bottom. So this looks like more steps because we made double steps underneath, because you can't get the CLT thick enough. But it was an opportunity to make the kind of if you look under a Georgian stair, they always make a kind of double step, because that gives you more drama. And that's Ben and Nigel putting it together. So if we started at the top, 4 days later they got to the top. And there's the compression spiral. It also acts like a thermal chimney. That's worth mentioning. So
yes.
Here you see the notches. So it's just like a puzzle. You go up, and we had to put little bits of plywood inside of one of the flights because
just to get it level.
Exactly, we couldn't get
orientation.
the thickness of the wood to the right sizes. So but that shows you that was all. This is all built in Rhino. That's Lockie, Dennis's son, right up at the top there. So that's the view from the underside, and these rods here, we put 2 per step, so they increase dramatically as they go around the corner. But that sort of serves to emphasize the sort of tightening of the curve. And then on the inside, Dennis managed to get the wood all wire brushed, which gives you this beautiful finish. So it wasn't a very expensive option, but it does make the wood so much more beautiful because it shows you the grain. That's looking down into the pit and up into the sky. And there's a sort of bath-like hole at the top there. And in the lift, there's also a hole, and it's messier in the lift there. It's an orange lift, and it has a skylight on top of the lift. And as you rise up, it goes up towards the light. So the higher you go, the brighter it gets. It's incredibly slow, but at least
you get there eventually.
Exactly, but it does get brighter as you go up. So that's the stair, and it's blank on the outside. So a lot of those sort of castle-like qualities, blankness, random windows, and then very large openings are all part of that sort of castle-like character of Castle Acre. And then here at the bottom of our tower, just a single door. And Dennis put a clock, which was an offering back to the village. And maybe, Dennis, it would be good to tell a little bit about, because what Dennis did was about 300 yards away, there's a pub called the Ostrich, and Dennis basically met nearly everyone who worked on the project, either in the Ostrich or in the village, and nearly everybody came from within a very small radius. And everyone knew the water tower because a lot of them had, childhood experiences climbing the tower, which are highly illegal, of course, but they all kind of knew it well. So there's the clock at the top, and we managed to do the top without a flashing. I hate flashings, and this is from a car door. It goes on, pops onto an old-fashioned car door, and it just covers the edge. And then on the inside, the waterproofing is dressed up inside that, so you see the ripple on the skyline. And then the stair acts as a thermal chimney, so all of the air moves up through it. So the building is kept incredibly cool, a bit like the buildings in Yemen again. They work in exactly the same principle. So you open the doors at the bottom, you open the windows at the top, and the whole thing, air just whistles up through it and keeps the whole thing cool. The stair is also a sort of conduit on the side there. You see that's where the MVHR is, so the air is sucked up and down, so the hot air that rises to the top is then pulled back down and put into the bottom again, and then all the energy comes from the air source heat pumps that's sort of hidden on the side of the site. And that's how the sort of servicing works. So, and just lastly, to talk about the tank. So obviously it's a steel tank, painted grey. It sits on steel joists, that sits on two very large RSJs. Made
up wrought iron panels.
Yeah, we
never figured out.
We never quite got it.
We think we are.
Yeah,
I think they're wrought iron. They might be.
But they're really beautiful. And this is what they look like on kind of day one with the kind of top light. And each one has a number on. And it has a number on because actually this isn't where the water tower started its life. It's it was actually somewhere else. It was on an airfield. And we think, Dennis thinks it might be from the 1930s, and then it was moved here in the 1950s, and it was reconstructed. And when you're in there, when you're in the water tank, you're very conscious that this was full of water, and the water level goes up and down, and there are all of these devices like ballcock you see across on the side there. So it's all about the level of the water. So it kind of came logical. Obviously, you want a view, but what people normally do in water towers is they make one great big window. And actually, we didn't feel that was the right thing because the inside of the tank is so beautiful. So we said that, and you're on the top of a hill and you really want to connect to the horizon. So we said the best thing would be if we could just sort of make a cut that went all the way through the tank. And this is Dennis did this with his son Harry. They knocked these out with a mallet, one by one, and I think the noise must have been amazing. But Dennis, you can explain that maybe the experience of that. But before we explain the structure.
Yeah, the tank. I mean, it was filthy inside. Amazing how people can drink water. I mean, obviously it was defunct for 10 years, but even after 10 years. Amazing amount of filth at the bottom of the tank. Don't know how we got away with that, or how the village is still alive. But anyway, yeah. So we used chain hoists and pulled the panels out one by one. And as we did the first one, it was really exciting. So we're using a sledgehammer and a chain hoist to pull them in from one wall to the other, but very beautiful. So we did this on a day where the field was full of rapeseed, so it was bright yellow. And as we went around one by one, we actually couldn't stop working that day. We worked and worked and worked because the view got bigger and bigger and bigger and more beautiful. So I think we overdid ourselves that day. It was great fun, really exciting to see that.
And what was amazing is we imagined we would have to leave one or two of the panels in to brace it, but Mervyn said, no, you can knock them all out. We'll just hold it the top of the tank up with the window frames.
Sure. And where we achieved this is the panels above the window, we converted them into trusses. So there's a truss which wraps around the perimeter of the building. And then those trusses then sit on little box frames, which are the 4 openable windows at that level. And because they were box frames, just 70 by 70 hollow sections, welded together at each corner to give a fixed joint, that provided not only vertical capacity to carry the weight of the panels plus the roof, but it also provided lateral stability. So we were able to achieve that with just a tiny little box frame. And it's basically the 4 box frames that support the whole of the roof and not much else. And
they're hidden behind the Velfac window, basically. So yeah. that's the plan of the and I think it was really logical for Dennis that actually, of course, the living room should be at the top. Shouldn't be the bedroom, because the living room will be shared by everybody, and that's where you want to cook, that's where you want to eat, that's where you're going to see the weather change. And here's the view of the truss. Yes, you can see the trusses above and below, and you can also see the glue laminated timber joists which span the full width of the water tank. Which ended up being quite deep because they had to take the twisting motion of the top of the tank back into the stair tower. Yes. And I think the next image shows.
Still taking out the panels.
Yeah, that's Harry enjoying the revealing view as it went. So, and then there's the sort of messy reality of the truss.
Yes.
With
The truss above and below the box frames.
Yeah.
Just angle bolted to the face of the wrought iron or cast iron panels, and then we use the panels to act as the diagonal cores of the truss. So we didn't. So it was just a series of horizontal and verticals, and we allowed we made the panels do some work as well. So they're not just sitting there; they're actually part of the truss themselves. They're working compositely.
I mean, when you look back, that's looking out of a short direction. I mean, you look back, I mean, that's the kitchen. And we mirrored the back of the kitchen, and you'll see that in one of the videos. So, but actually, it seems like the horizontal slit goes all the way across. Yeah. So there's the big opening at the back, and the cuts. That's before the panels had all been taken out.
And this is the plan of the water tank floor, which have the original RSJs in the secondary RSJs supported on 2 primary RSJs. And of course, it wasn't because of the panels, there was a lot of relief in the floor surface. So it was good to pour a layer of concrete over the whole area to provide a flat surface for the floor, but also to give more mass and inertia to the water tank. And on the right hand side, you can see the roof plan with the glue laminated timber joists.
And it shows you the round void over the lift and the bath shaped void over the stair. And this is just a detail of the window frame, so showing you how we hid the frame behind the Velfax. So we love Velfax, but we like to hide them.
Yes. And
that's the view from the top. And it shows you the roof is very seamless, and it has, I think, that 8 PVs, and then the building behind on the ground there, that's covered in PVs too.
And the roof terrace itself literally sits on profiles above the waterproofing, so that the water is always washing away from anything that sits on top of the waterproofing, so keeps it safe and robust. And it just literally floats on there, and kept in place by its own inertia.
Well, it's an incredibly, there's a lot of steel on top of there, isn't there?
Yeah.
And actually we needed that mass because we didn't want to flutter. When you get 100-mile-an-hour wind, you don't want the terrace flapping about, basically. I think we've shown that one. That's what it's like when the concrete's poured, and shows you the window frames, and you just see the Velux handles there. I mean, in the center of a plan, because if there was no light in the middle of a plan, these would always be in kind of you'd see them dark, and they'd be in sort of silhouette. So the idea of putting the skylight in the center was to bring light into the middle of the plan. And so there's a large walk-on skylight that's in the center, you see on the right here. And that's just flush with the ground, and there's a timber deck. Because it's flush and flat, the water settles on it when it rains, and then that water then blows in the wind, and when the sunlight comes through the water, you see the reflections of that moving around. So you get these moving reflections of light. So because it's mirrored on all 4 sides, it doesn't matter where the sun is, the sun always comes into the middle, and it's very unpredictable. And this is a little video Dennis made of that sort of the unpredictable nature of the skylight, which also glows at night. The top has a light there as well. And if that was a movie, that would be all sort of moving light. And then Dennis, I put that picture in of the red kite. And what Dennis is finding is that slit basically is always sort of interconnecting you with what's happening around the tower, which is quite often kestrels and kites. And
Mike, that was a kestrel, not
that was a kestrel, was it? Oh, the red
no
kite
string, no string attached.
the red kite one movie is really beautiful. I don't know if I can get that up later, but this is
Mike, I think we might be
okay.
Heading to go into live video, don't you think?
Okay, all right. This is dawn, the sun coming up, what it's like when you look through it. There's the tank, and there it is at night. And now this is, yeah. So I think, Dennis, you this is You made this with the drone, Dennis, yeah?
Yeah.
And actually, you see the mirror here works quite effectively because it looks like you're looking straight through it. It zooms. It takes a minute, but whether you want to wait for the whole thing or just head off with reality, Dennis.
No, this is nice. I like this bit of footage.
Yeah. So in a way, the kind of archetype is a sort of ruin, but it's also like a hide, because it gives you that kind of room looking out onto the horizon, but also lets you sort of see what's, when the storm approaches, it's really amazing because it doesn't matter where the storm's coming from, you see it first here, and because you're right on top of the hill, basically.
Cool.
Okay. Well, do you want to, if I stop sharing,
Yeah.
and then I think we go to,
Oh,
hang on.
me. Hang on. I'm sure I can just flip my camera.
Yeah.
Here we are. So the outside. What can we say? Let me just have a little walk around so you can see all angles before I take you in. Pardon? Did somebody say something?
Sorry, that was just me.
Just having a little rove around just to see.
The advantage of putting the window facing north was, in Japan, they always face the windows north because it's much more beautiful to look at something that the sunlight is landing on. It also meant that the window faced away from the village. Oh, and the other thing I just forgot to tell you about the stair, which is really nice. In castles, staircases always rise clockwise. And that's because if you're a right-handed defender, you can walk backwards up the stairs and stay alive.
With a sword in your hand.
With a sword in your hand, yeah. So,
Right, I must remember that when I get have an attack.
It could have gone the other way, but actually it just happened to work out nicely for us. But oh, we nearly saw the code there, Dennis.
I can quickly change that. Right. Here we are. Here we are on the inside. Concrete floor, which is actually
Polished.
very nicely polished.
Polished ground.
Okay. As Mike said earlier, this is the garden room where we just hang out, get changed when we've come in wet, or it also is a self-contained little flat in a way, because in through here we have a little kitchen. There's a fridge down there and a washing machine, and a bed, as you saw. Also, there's a little wet room in there. We were thinking about buying a dog, but we haven't got there yet. Where are we? So this is interesting. So up here, behind the plants that are doing really well, is all the services. The MVHR, which is behind there, and accessible via the old ladder from the original tower. Okay, let me take you into the stairwell. Let's see if I can get there. Yeah.
So these, in the tank, you saw the ties that were holding the tank from expanding outwards.
Yes.
And here, the holes are drilled into the treads, and they're simply just grip filled into the treads. We love a grip fill detail.
I could do grip fill detail.
Yeah. Oh, there you go. And the wood wasn't the highest grade, Dennis, was it? It was a kind of affordable grade, and then the flooring, yeah, engineered floor. So you're on the bridge now. So you're up
on the bridge. Have a look
bridge.
outside.
Yeah.
On the other side of the bridge.
Yeah.
and into the bedroom.
Actually, Dennis, because you acted as the main contractor, I think, because and Dennis is a photographer, as we mentioned, and does sort of very detailed work. And when you're there, you'll see that the details, everything's impeccably done. And
yeah, well, I think that's down to the woodworker, really. I mean, I drew out some details, and he followed the drawings. We used plywood for doors and door frames. I just bought a big block of plywood, spruce ply, because actually the CLT is spruce, and it seemed like a really cheap option to make everything up. As everything is bespoke here anyway, it just seemed the right thing to do, and I just bought a large block. This is, I mean, when we designed this, Mike, I guess we designed it with kids in mind.
yeah.
And our kids have all grown up now. So, these beds haven't been slept in for a little while, which is kind of funny. Although Nemo did spend the weekend here this weekend. So here we go. This is a little detail from the ladder, and again with spruce ply, bolted from the back with a little weld. Also, again, these are the bars from the tank. Lots of reuse. I mean, we were intending to reuse everything. We only had 2 skips of junk out of this build, which is pretty small, I think. We did reuse all sorts of things, including the old pipes and fittings, as you'll see when we get to the top.
Oh, and the tank bits that came out, Dennis, can we tell them about that?
The actual panels.
The panels.
Reusing the panels. Yes.
Oh yes, of course. When we get, so next bedroom. And so the panels from the tank are down there. That's the terrace I was close to earlier, but we don't call it the terrace, we call it the ferrace, because all of those panels down there are cast iron and from the tank, from the removed panels from the windows. And again, didn't show you the bathroom, but I guess that works out quite well. I mean, it was beautiful out there yesterday, looking really stunning. There are no pictures in this house because we don't need any. Each room has its own view and big windows up the stairs.
There's a nice moment in the stair where the oval skylight projects into it a heart-shaped beam of light, which occasionally, when it's in the corner.
Oh yeah, there's a little slither of it there, but
there you go. Sometimes that moves across and makes a heart in the corner, which is very nice. Completely unpredicted, of course.
Right, and here we are at the tank.
That's the window frame. Yeah.
Box frame.
Box frame, yeah.
The box frame, yeah, amazing. I always still wonder how Mervyn managed to do that. It's only sitting on this, you know.
I did lose a lot of sleep over that.
So did I. Yeah, an amazing place to watch the birds go by. I mean, incredible. You know, last night I just had 2 geese just fly maybe 10 foot from the window.
Wow,
that's incredible. So I'm an ex-painter and decorator. Last thing I wanted to have is paint on the walls. So we've got these rusty panels, and they've got numbers on them.
visual numbers. Wow.
And the numbers are, I'm imagining, because it was on an airfield in Massingham, that the numbers were put on there in the 1950s when it was dismantled and brought to the village.
Dennis, do you get rust? Do you get it rusting?
No, not at all. No, it's all sealed.
It's all sealed.
There is still a slight smell of ferrous in the room, though, isn't there? Which is actually a nice thing, you know. But
Not anymore, Mike. No,
no, that's gone, has it?
That's gone.
Yeah.
no, it smells nice in here now.
Yeah.
Let me take you on.
Someone who needs more iron.
Oh, sorry. I haven't-
See the mirrored.
So that's the mirrored background that Mike was talking about, which the wall where there is no view, suddenly there is a view, which is really a very nice detail. And oh yes, this is the old ball cock, which has some amazing patina, as well as this one. I mean, everybody looks at this and goes, "Wow, it looks like Saturn."
Mm-hmm.
Which it does, and reused as lights. The plants are doing really well. Amazing. People keep asking me if they're plastic. I don't know what that's about. But anyway, I wouldn't put plastic.
What about the skylight, Dennis? Oh, we missed that. We can look down on the skylight to see the mirrors going around.
Oh yeah, let's look down on the skylight. We're going up.
So here the balustrade just rises up higher. So it creates a kind of level with the deck.
Safe access onto the roof.
And it's okay for the PVs to be flat because actually you can get to them to clean them very easily. So rather than inclining them. On the terrace, the boys sleep on the terrace sometimes, and I mean that must be amazing to just sleep with the stars above you like that. But it obviously needs to be the right night.
Yeah, I mean, we always imagined that we were going to spend a lot more time on the terrace, and in fact, we literally only ever come up here when we have visitors who want to see the roof. It's quite funny. We went through quite a difficult time trying to get permission to use the terrace, anyway. But we do use it occasionally, but. When and then we stepped with a few bits. Oh yeah, Mike, you wanted to see?
Oh yeah, it looks great.
The polytunnel.
New patch of land.
Wow.
Yeah. It's quite a big lump. It's a lot to do. Yeah, we've got a digger and a dumper down there. So I was digger driving and dumping this week.
What's
I've
the
learned some
horseshoe
new
shape?
skills. The horseshoe shape, yeah.
Yeah,
That we've got a plan for that.
it looks good. Looks like something Neolithic.
Well, it probably. Well, it was done with a digger and dump. Not quite. So, where do we go from here? I'll tell you what, I'm going to get out of the cold.
Well, that's pretty good timing. We said we'd finish at 10:02, and that's almost spot on, Dennis. So
Nice tour.
yeah,
Pretty good.
and that's a cattle trough, I think, as the plant of it. Which actually that juniper tree is doing all right, Dennis.
I hope it's not too heavy.
Probably holding it down.
Yes.
Yeah, thanks, Millie. Yeah, well, it is the most amazing place to live. I've literally been here for 2 weeks now, solid. Actually, no, I nipped back into London for a couple of hours last Friday. But yeah, I'm spending most of my time here when I'm not at work.
Amazing.
Yeah. Right.
Well, a huge thank you for that. We've seen so much, and it's seen the detailing right up close. Again, it's been really brilliant. There's a few questions coming, Dennis, as well. So I think, and I think I'll just come to the one first because I think you can probably, well, I don't know, both of all you can explain it. Could you explain a little more about the flashing detail to the top of the Wrigley tin?
Yes, let me go and show you in detail. So that is something I found because we were wondering how to create this.
And while Dennis is rushing off to show us in person, if there's any more questions.
There it is, yeah. So it's a bit of plastic
Yeah.
that would normally go on the side of a car door if you have an old car like an Austin A40 or something like that.
Yeah, use them in caravans and that kind of thing, boats, caravans. It's just a bit of
The waterproof addresses up to the underside of it.
Yeah.
yeah, but it nipped the rubber together very nicely, and it's got a nice little wriggle to the top of it. Yeah.
It
brilliant,
keeps the
thank you.
wriggle in the wriggly tin, doesn't it?
And it protects it then from water and
Yeah.
and the environment. Another question. Can you tell us a bit more about the surveying process and how you decided that the original materials and components of the water tower could be reused again? Obviously coming in for reuse of materials.
Well, I think the whole thing was reuse was quite high on the agenda, and not throwing anything away. Why would you really? You know, when I was up at the auction, there was somebody else bidding, and I would imagine that this person bidding for
But also things like the rods would have been
bidding
more time.
Yeah, I mean,
so good in bending. So the rods would have been good in bending, and the cast iron panels are good in playing axial loads. So it lent itself to be reused and work compositely together. So.
And then you have to do an extra survey of obviously the footings, because you've added all that extra weight to the building, but you said you think they were substantial in the first place.
Yes. I mean, we didn't really because we worked out the weight of the total weight of the water plus the tank was about 2,000 kilonewtons. And then when we looked at the load, the additional compression from the increased wind elevation, it came to about 250 kilonewtons. So you know, it was still at half capacity. So we were very reassured, and because the foundations had to be quite a large mass in order to carry the 2,000 kilonewtons, then that acted as a counterbalance as well, so it didn't tip over as well in the wind. So it gave us the push-pull effect, which works well from a structural point of view.
Yeah, thanks, Mervyn. Another question. They're saying it about boring, but I think it's essential. It's a boring question. What about services and drainage? No more to that question.
services and drainage.
The services all rise up behind the bathroom pod. And Dennis showed the kind of plant room up on the mezzanine level, so they all run up there. But there was an existing pipeline, obviously, from the water, that took the water to the village, and I think that same pipeline got reused, Dennis, didn't it? And
as a conduit for a new pipe, and also for for some electricity cables too. So I reused the old conduit. Also reuse the soakaway as well. We have a rainwater collection point as drainage. We put in quite a big rainwater tank. One of the reasons for that is so that it can be used for sprinklers. I've had to put fire sprinklers in, and the other one's for gardening.
What about sewage? Is there a septic tank? That must have been new.
Well, it's not a septic tank actually. It's a sewage plant, right. So it's constantly having air pumped into it, which breaks down the bacteria.
And then
brilliant.
The overflow from that is straight into
the farmer's field.
Right.
No. It's actually 98% water is pushed out of that, and then occasionally every 2 years you get it cleaned out.
Right.
Yeah. quite self-sufficient. Another question, how do you find the acoustics within the building, but mostly within the water tank at the top with all the hard surfaces?
Well, I do know I've got a really amazing sound system, and it's people have been here, and the acoustics are incredible. I think it's to do with all the fins, all of these back fins on the tank, on the tank panel. You know, these things, the sound just doesn't bounce around. It's like being in a recording studio. It's great.
Oh wow.
Also, the chairs are probably helping.
You have some soft things.
Exactly, and having people in it too is a good thing. Yeah.
So more of a happy accident than a design intent.
You didn't want to cover up those panels, so whatever it was going to be, it was going to be.
Yeah, that's right. Yeah,
Could have been harsh.
Like there were many happy accidents, but the concrete floor being one of them, actually, because they were going to pour some grey concrete, and they poured the wrong one. So
you polished it. But Dennis, that's concrete. That's a screed on top of insulation, on top of the concrete infill in the panels, isn't it? So that that floor is thermally isolated.
Underfloor heating.
Yeah.
And then the concrete floor on top. Yeah.
So the 2 layers of concrete there to isolate it.
Yeah.
Great. Thank you for sharing the detailing. A final question, because I know we're getting close to the end of time. You know, it was great to see the detailing in practice, especially around the external cladding and internal timber works. What was the corrugated cladding system that was used?
It's a steel sheet with nickel. It's not
called Alu zinc. Alu zinc.
Yeah. Which has it doesn't change, and it's actually a very highly reflective, and that's why you get this nice reflection of light, and it's not going to kind of weather.
It won't dull, will it?
And it won't dull
because of the aluminium content.
Exactly. Yeah. So it's going to stay like it is, and in a way, it's also sort of grey, like the castle walls and all the ruins, and with the random windows. But there's a lot of Boston ivy planted around the building, but it's taking a while to take hold, Dennis, isn't it? Because it's so windy. But I would say maybe 20 years, the whole thing will be red.
Right.
So when it'll become more part of a Castle Acre ruin set, then I think.
Yeah. Also, it gives a feeling for the agriculture that is around here too. So it looks a bit agricultural.
Does the cladding get quite hot in the sunlight? So will that prevent the Boston ivy going up the walls?
No. The Boston ivy is on its way up. It's doing really well at the moment.
Oh, right. Okay.
No. I think it'll get to a certain point where it just goes.
It covers it,
exactly.
and then it will shade it. It won't get hot.
And it'll be beautiful, not from a setting sun, but from the Boston ivy itself. So then the connections to the seasons will be even more beautiful.
Yeah.
We look forward to seeing further photographs. And so on that note, there is a case study prepared, I think, by my colleague Bryony. And it's just a huge thank you, well, Dennis, for sharing us your home, for having the mad idea to build a water, to actually think you can build a home in a water tower, and for Mike for actually taking the commission on, and then Mervyn for sorting out all the engineering. And it's just come across so well that you had such fun on this, and as you said, the happy mistakes and all the detailing you learned. So I can't say a big enough thank you for coming and sharing that with us. I mean, if there is ever a chance for a tour, I'm sure any of you ever do open it to the public, I should please put it out there. I'm sure there will be people absolutely fascinated to come and see it.
I do have, sorry, can I just interrupt with an Instagram account, a water tower project?
Yeah.
If I put it up as an open day, we can put, I'll be putting it on the Instagram account. Okay.
Dennis, thank you for that. And you might get inundated with that. So our next, so this is recorded and it will be up on our YouTube channel in the next couple of days. Thank you for all our speakers. Thank you to all who attended. Lots and lots of lessons learnt. If you would like to come and join us for the next session, that is on the March House on the 19th of April. Knox Boven, Price and Myers and Block Build, a completely different scale to what we had the pleasure of seeing today. And with that, I just say thank you for joining us, and we look forward to seeing you next time.